Want to explain why that Ford starter stayed on? We can do that. What else you guys want to talk about?
I can take this down because that's actually better representation.
This is an X and that's a divide. Right?
And this is in those videos. What else do we want to talk about? You want to know about catalytic converters? Let's keep it electrical as long as we can here and get that actually down. So symbols.
Like how to diag your O2 sensor.
Ooh, that's a good one. Symbols, O2 sensor.
What else? I want a diagram, man. I really want a diagram.
Mass airflow sensor.
Oh yeah. Mass airflow sensors. That's kind of on the other side of electrical, but.
That was gonna get interesting. I
Yeah.
watched a couple of videos once, and I'm like,
And you wanted to know about how to do,
like
Catalytic conversion.
frequency, some reads. Yeah. So cool.
all right. And I would like to do PWM. Anybody know what PWM means? Pulse width modulated.
No, I have no clue.
No clue, huh?
Is that what you're doing on the lab scope when we do that? Or?
You can watch a pulse width modulated solenoid. Yes. So let's start with the Ford starter. Okay. So this is Ford. We got a battery over here. Power. Negative. So power comes. It splits off. There's a splice. I'm gonna draw a splice, a circle. It goes to the starter and goes to the relay. So I'll put a relay here. Actually, they're round. So with this. So Ford starter relays are round. They got the two terminals on them.
Like 4.
That, and they got the little one here that goes to the power. I think it goes to the. I'll probably go to the ground.
Daniel's here.
Yep, Daniel's here. And then this one here goes to the starter. And let's draw a starter solenoid here. Big wire. The wire goes to starter. Mike's better drawing this. He drew that pretty good one last night. And then you have that's a big power. So this is 500 amps load. And you have the signal wire that goes from here to the little guy here. And this is like, this probably might draw 10 amps. So that's why they have to have that, because this, I guess a Ford starter draws probably more than what a relay can do. Morning, Daniel. So, all right, so then you also have an alternator. Kind of what it looks like. You have the big lug on the alternator. That's going to produce voltage. And here's the problem they did. So if you put voltage on this wire, it engages the starter. I feel like I can't hardly. Can you move over there? I feel like I'm like trying to stagger road. If you put voltage on this wire, it engages the starter. There's one like Mike drew yesterday. Oh, there's one here too. So this goes to the, and then everything is grounded. So ground there and ground to that. So this is, put a key switch in here. So up here, switch, and so that way, and then over here it is the dotted line, and that there goes to here.
Are you drawing this like a wiring diagram would be, like the symbols?
Yeah.
The wire?
Okay, so I have to put, connector here.
I mean, you don't have to make it super in depth, but like
C201.
if it said a starter or whatever, are you drawing it kind of like a?
This is the alt. This is the starter.
Really be set up in it.
And this is a solenoid. Now this is on an F-150. Chevys don't have it this way. This is a battery, you know what that is. So this is a ignition switch. So when this closes, when you turn the key on, this closes. Battery power goes to here. Powers the one of the small lugs, the other one goes to ground. When that happens, this connects. Basically, let's, think of it like this, and then when you have a magnetic, actually right between here is a magnetic coil like that, and it makes it go down here like that, just like that relay we drew yesterday. Okay? When that happens, you get power here, you get power there, and you have power at ground. That's another relay, so it engages the starter. That makes sense to everybody? Okay. Now, this is what the customer did before they brought the thing to us. They replaced that solenoid on the side. However, the starter was still bad. So Andrew put a new starter on it, hit the key, the starter stayed on. It burnt the new one up, right? Smoking. Burned it up bad. Okay, because it just stayed into the ring gear and it just sat there and smoked. What happened is the customer replaced the solenoid.
Where's
And
the solenoid at?
It's on the firewall.
Okay.
It's on the firewall.
Either of us like this.
It's like that big around. Looks like a glow plug solenoid relay on Ford Power Stroke 7.3. It looks exactly, it might even be the same part number, I don't know. So normally the alternator produces voltage. Let's just put this for representation. Voltage is coming this way. Normally they put it to this top one so it has a direct path back to the battery. That make sense?
Mm-hmm.
It charges the battery. However, it is on the same lug, but it's on the one that goes straight back to the battery so I can refill the battery. That's not what they did. They put it right here. They hooked that lug. So as soon as that alternator produced voltage, it produced voltage right back to this thing right here. Where's that voltage go? That holds the starter on. Exactly what they did.
So they put it on, it still wouldn't start. They hooked it up wrong, and it still wouldn't start, so they didn't know that they hooked it up wrong.
So that thing probably wasn't even bad. They put it on, it still didn't start. Their starter was probably bad, but they replaced the solenoid first. They put it on incorrectly. They did this, and it still didn't start, because the starter was still bad. And then we put a new starter on it. We did everything right. Andrew didn't do nothing wrong, except for later on after it was engaged. I don't know if you could hear it or not, but
Jeremy's like, are you sure that's the starter?
so.
Yeah. We went and looked it up, and I looked at it.
Morning.
Smoke on
Hey, there's our AC guys.
What?
There's our AC guys putting our AC in.
Yay!
All right.
So I did not have a
Does that make sense? Okay.
So if you come across a similar situation, would it be best to start with the starter instead of going to the solenoid?
The stroke doesn't start. The first thing you do is you do your test right here. You check to make sure you're getting power here when the ignition's turned on.
Okay.
Make sure that test light lights. So honestly, I would go between, clip your little test light on here and go up here. There's a test light bulb down to here. Hey, hit the starter. If that test light lights, second thing I would do is I would go from there and I would go right to here with the test light and make sure I actually put it on the lug right there. On the starter, on the actual, not on the nut, I actually put it on the lug sticking out.
Probably wouldn't be
Because you
a
can
bad
have all kinds of bad connections and stupid stuff happen.
Wouldn't be a bad idea to put a actual voltmeter on there though, right? Make sure you have your right voltage going there, because you could have a corroded power wire or whatever.
Will that test light light?
As long as you have some voltage, won't it?
Okay, so go back to the volts, ohms, and amps thing again. Let's say this power wire, it's supposed to be able to do 500 amps. It has a connector right here. It's backwards. C10. It has a connector right here. And that connector is really corroded and nasty. And then comes down here to this. Connector C102, let's say you put a voltmeter on there. If he hits it, and basically right now there's no load on here, there's 0 ohms. If he hits it and make it have 0.5 ohms, it will pull that all the way to ground, and that is you're gonna have 12 volts, 12 volts, 12 volts, 12 volts, 12 volts until he hits the solenoid. When he hits the solenoid, this section of the wire right here is gonna go to nothing. So the quickest and fastest way is take a test light, go between the body of the starter, and go right through here, just like this light here.
So it won't
If he
light
hits
it
that
all.
and it stays nice and bright, and he hits that and that one stays nice and bright, that starter is garbage. It's the easiest, quickest, fastest way to test that. Does that make sense to you, Andrew? You test
Because
the starter
you're
before.
actually clipping onto the starter and you're
If you can get a
getting
good,
the light.
if you can get a good thing, that way.
Well, I'm saying that's testing your ground too, all at
That's
the same time.
exactly. If you put right here, you don't have to worry about the starter ever getting ground. I've maybe seen one starter not get
That's
ground.
legitimate.
It almost never happens, but that one time you don't check it is probably the time. So if you clip on the starter, clip there, you few test lights, you're done. And then if you have both of those lit up, so this stays on solid, and this in here, when they hit it, the little tiny wire will have juice.
So
If it doesn't, and if it's a Chevy or a Ford, you take a hammer and go and say, hold it on, and you smack the side of it, and it goes, then you know for sure it started too.
it's technically grounding where the bolt holes are at, right, to the block.
Yeah. Yeah.
So I mean, if you're not getting a good ground,
You
take
could
it
have a
off
bad
completely.
ground strap clear to the, you could have a bad ground strap to the engine. That's why you would check it right to there. I may have seen that happen a couple times. A lot of times it starts to fry stuff, and cause you're trying to put 500 amps through like mounts and wires and cables. I think you're getting accelerated cables. Trying to hold 500 amps, it ain't gonna work. It's gonna smoke. Does that make sense to everybody? You have any questions? You know what a fusible link is? They don't hardly ever use them anymore.
I've seen them on the, like lasers or the alternators.
They're usually like a wire, and then it gets like a little bit bigger and it's black, and then it gets smaller again. And it says, a lot of times it'll say fusible link on it. Sometimes they're just a wire and it says
You
fusible
don't
link
even
on it.
know, really. You have to like test the wire.
And then you have, because sometimes they use those like, I don't even know how to draw a fusible link, but they might use a fusible link in here where this just gets bigger. It might say fuse link. Ford used those a long time ago. They're dumb, I think. They're kind of like a slow blow fuse. Do you have another question about that? I want questions because that helps me out a whole lot if you guys ask a whole bunch of questions. There's no dumb questions.
So, what would be the procedure if those lights, you said if they light up, then you know it's a bad starter?
Yep, if both of those light, if this one stays lit when that one lights, I always check that one first to make sure that we get a signal. A lot of times you'll hear it go clink, clink, but if this is completely open and bad inside, you won't hear that.
So that's like the best case scenario in wire diagnosing. What's
Yes, I
the
check
worst?
the little guy first, and if that has juice when they crank it, then I make sure that when they hit the thing, the other one doesn't go away.
So
Make
what
sure
happens?
If you don't have a signal wire.
What?
Say the signal wire is
Yeah.
Mm-hmm. Okay.
lighting up.
Let's say the signal wire doesn't work. First thing I would do is do that. What would you do, Andrew?
Go back to that solenoid.
Okay, and what would you do there?
See if you got power going there on the key.
You could, but let's say I want to make sure that all the rest of the circuit, all the high side circuit's good. So this is the high amps. This is the high amps. And these here are just control, like the relay control. It's kind of hard to see, but like, this is the relay control. Your ignition switch won't take high amps. That's why they have that there.
Yeah, that's what I was saying. Like,
Yeah.
you go on that solenoid that mounts in the firewall.
What would you do? Did you see what I did the other day or not? What'd I do?
I walked out there towards the end, but I would put take your test light, stick it on the firewall or on the battery, and see when you hit the key, make sure you see if you got power going right to the bottom post when you hit the switch on.
What? Switches? Okay. First thing I would do, take my test light or a screwdriver, cross this thing over, cross the big lugs over,
Okay.
and see if it'll do the work. What that'll do, again, I'm splitting the system in half. That tells me, is all of the high amp circuit good? If I cross it over and the starter starts, I know the high amp circuit's good. Then I gotta chase either this is bad, or this thing's confusing. Let me get this out of here. It just is, there's too many wires here. Either the high amps, we know the high amp circuit's good because it'll start it. Either the ignition switch could be bad, you could have a bad wire here, you could have a bad ground right here,
Bad wire from power to the switch.
you could have a bad wire anywhere. So if that happened, the second thing I would do is I would take a test light and I would go from ground, and I would go, It's gonna be complicated here. That's really not where I wanna go. From ground, I would go right to this lug right here, to the signal wire. It might even say S on it. And I would make sure that when I hit the ignition switch, I'm actually getting power there with the test light. Test light.
But if you spark it and it pops off, it's gonna tell you you're getting power there too, right?
If I what?
If you spark it with a screwdriver.
If you went from the power lug to that one, you could do that. So let's say we didn't have power here. Let's say we didn't have power. You could jump the power to the you can jump the power to there and make sure that the actual relay works. Then we test that. We'll split that out of the system, make sure that's good. Does that make sense how you do that? You can also cross. You know how to cross a starter over? You know how to cross a starter over?
Kind of like
Yeah.
basically
Really
solenoid
easy.
on the fire.
No, let's ignore all that stuff except for the power and the ground. So ignore everything here. Everything. So do you know how to cross a starter over? Not really?
Then you, like the same way you do it on the firewall, right?
Kind of, but if you cross the little signal wire to the big wire coming in, that'll supply power to the signal wire, which will suck the relay in, or the solenoid, same thing kind of. It'll suck it in and make it start.
You gotta put your ground on the body.
Well, this is, yeah, let's just assume this is.
Well,
this is
if the starter's off, I guess. Off the car is what I was saying.
oh, yeah.
Like to test it once you got it
Yeah.
off or whatever.
Yeah. But you can do it on the car too. All you gotta do is take a screwdriver or something and make sure, because you got 500 amps there, you hit the screwdriver from there to ground, it'll make stuff hot real quick. It's got a lot of amps. All the circuits are good. It can do a lot of work.
They'll make a screwdriver hot too after.
Yeah, you'll have a 10, 13 millimeter wrench that has a burn in it forever. Might be one of those in my box, man.
I've got a couple of them.
Okay. Starter, fusible links, ignition switches. You guys good with that? You guys got it?
Something that you can already say, I'm good with that.
Okay.
Something I think that would be like beneficial is like if we do a topic on something on the board
Uh-huh.
and we had something come in and it's not like super urgent, had to be done that day. If like we could work through it out here. I mean, obviously shop would get the time, nobody out here would get time for it,
Yeah,
but
yeah.
like we could work through it. If it was something we went over on the board.
So eventually, once we get, I'm gonna do PWM next. So we got that done. I'm gonna do PWM next, and that will make more sense on how stuff works. This is, so pulse width modulated is how a cam phaser solenoid adjusts the cam right where it wants it, and then the computer watches it and it moves it, and it's more, less, it puts it right where it wants it, and it's a closed loop. It's watching where it's at and it's adjusting all the time to make it right where it wants to be. Everything else changes, but it adjusts it and keeps it there. So that's one thing. Purge solenoids is another PWM, because they let more and less through based on what the computer wants. There's a lot of things that PWM on cars. You ever hop in a car and then you shut the door? GMs do this. You shut the door and it goes, lights go down?
Yep.
That's pulse width modulated signal. Computers pulse width modulating that to nothing. They use them in transmissions a lot, line pressure on transmissions. Your CP3 pump on your diesel, that little solenoid, 2-wire solenoid, that's PWM. What else is PWM? Oh man, there is a lot of PWM stuff. So you guys understood yesterday the graph I drew up here of 12 amps and 0 amps. So I'm gonna draw the same thing. Only I'm gonna draw a scope. Just to show you how, once I started using the scope, my mind clicked with how stuff works a lot better. So basically, again, this is a scope, and this is, we're just gonna use 12 volts. 12 volts, 0 volts, and this is, let's say this here, this is your time base. This is going to be 1 second. Okay? So let's say we're going to run a purge solenoid.
Would an injector be a PWM?
It is, but it's not like a 0 to 100%. You never run an injector at 100%. So per solenoid at 50%. 50%, they call it duty cycle. Right there. And what's the duty cycle symbol? It's on your scan tool. I can't think, or your flutes. You could, yeah, hearts, HZ. Duty cycle. There's a symbol for it, but I don't know what it looks like. So this is time. So we're going to draw 10 things here. So before it starts, down here at 0, computer remember that the little transistor we drew up here? It looks something like this, and then you got like temperature. I don't know how it exactly looks, and then you got another thing going out here. That's kind of a transistor, what it looks like in a computer. So that transistor is off. There's a little guy up here that makes a decision. That's how I look at it. Somebody makes a decision. The executive. They actually kind of talk about that in some of the things. The executive makes a decision to turn that thing on. And makes a decision and turns it on, goes to 12 volts. Okay? It goes over for 1 second, or 1/10 of a second, goes down. This amount, at 50% duty cycle, the amount of on time and the amount of off time is exactly the same. That makes sense?
Yep.
So in real time, it's only running at half of the time. So it's 50% duty cycle. Alternators. Alternators are a great one. All the new alternators, Dodge, that Caravan right there, pretty sure it has a duty cycle. For the field, the computer controls it and tells it how much to. This little guy makes a decision and says up the amp, up the volts, up the volts. Too many volts, load them down. So it always varies. So that's a 50% duty cycle on a per solenoid. Let's say this car just starts up and it's gonna duty cycle this thing at 25%. So goes over here, goes up, goes over. So at 25%, this time and this time would be half of this time, or yeah, half of that time. Go over here, little skinny line, back down. Make sense, guys?
Mm-hmm.
It's on only 25%. Okay? Does that make sense?
What
That's
would
actually-
we be talking about? What system?
What system? Actually, the alternator on that van, it might be doing exactly that.
It's only charging 25% of the time?
It's a duty cycle, so let's say they usually do, it could be 100%. Let's say it's on all the time. You put 12 volts to that thing, it's going to charge 100% as much as it can. You want to make it track my face again, see if it will?
Already on it. Yep, you're good.
What was he talking about?
Playing with the lab scope and
Yeah. Does everybody kind of understand that? So per solenoid, they would probably do the opposite way. Now, most things are GCC, ground side control. GSC, right? Ground side control. I think that's what they call it. So most things have power. Let's say, I'm just going to draw a per solenoid. So it's got 12 volts, comes down, you get your per solenoid, goes like this, comes out the bottom, and then this goes down to ground. So that's ground side control circuit. When this guy says, I don't need you to be grounded out, and he doesn't make a path to ground, there's 12 volts, 12 volts, 12 volts, 12 volts, because this has ohms, there's still 12 volts coming out here. There's also another guy at the computer. Let's just try the computer here.
Oh, so it's a full console.
It's a what?
Full console.
Dude, it's all the programming, but it really makes these decisions. There's another guy looking here. So this is this would be a, you ever do a per canister or EVAP vent solenoid on a GM? You ever do one of those? Never? Okay. This had a 446, I believe, EVAP vent circuit open, I think. So this is the guy that says that. There's a guy sitting here just like I am. He's watching this right here. So right now, this guy. So right now we got 12 volts, 12 volts, 12 volts. Clear to this transistor. Right now, what's that guy want to see? They're talking. They got a little microphone here, little telephone. They're talking back and forth. This guy says, "I'm off, I'm off, I'm off." What's this guy want to see when this guy's telling him he's off? What's this guy want to see? 12 volts, right? 12 volts all the way down to here. Okay. He said, "Okay, we're good, we're good." Then all of a sudden, this guy says, "I'm on." This drops down to from 12 volts. 0 volts. That guy drops to 0 volts, and that guy says, "Okay, yep, you're 0 volts, you're on. I'm not gonna set any codes, I'm not gonna flag you today. You're good." And then as soon as this guy says, "Hey, I turned it back off again," that wants to see 12 volts right there. So what happens is, on a Chevy truck, 2005, GMC, Chevy, whatever, this solenoid is garbage. And it goes like that. So we got 12 volts, 12 volts, 12 volts, 12 volts, 12 volts, 0 volts, 0 volts, 0 volts. And this guy says, "I'm off." So this is supposed to be 12 volts. And this little guy says, "You're on. There's 0 volts there, you're on." Oh, the other option, and the logic is that this guy knows that that circuit is not actually complete. And so he sets a PO for 23 or something. It's not a 446, that's the evap, small leak code, I think. So this is that solenoid. So that's it. I mean, that's exactly how it works. And there is, guys, in here, you can get a lot more in depth in what's inside a computer. And some diagrams will show you all, not these little guys, but they'll show you this will go to nothing right here. Some diagrams look like this. They just have something going off like this. And you know, you're supposed to know, that that is just the computer looking at that. It looks at it right there as soon as it comes in. If that makes sense? Okay. What other questions? That's a ground side control. It controls the ground. A lot of stuff has power after the ignition switch. So we have a 12 volts, comes down, and then it has the ignition switch here. And then that's ignition switch. It also probably would have a fuse after that. 10 amps or whatever. Does that make sense? So there's not always power at your vent solenoid. There's not always going to be power here when your ignition is off. Some things are, but it's kind of rare. It's tight to keep a live power. That makes sense? So, okay, great, let's do this. I have a way, I love testing these things. I've probably replaced 40 of them, 50 of them. And these things on Chevys, this is particular Chevy. Other ones work the same too, but the Chevys go bad all the time. Comes in, it's got this code. I don't know exactly what the code is. It says evap vent solenoid circuit open/short. Okay? I know these fail a lot, but what can I use instantly within like 2 minutes with a scan tool to tell that that is in fact bad, electrically bad?
With a scan tool?
I use a scan tool as one thing. So let's say this is turned on. Fuse is good. We got power there. How can I check all this circuit and all this circuit really, really, really quick?
Can you turn it on and off with the computer?
You can. You can tell this guy, hey, you can be the guy over here with the scan tool, snap on Solus. You punch the buttons here and it talks to this guy here. Right? No, it talks to the actual guy. It says, turn me on, turn me off. We have the ability to, it's called bidirectional controls. That's the right one, isn't it?
Is that what you do?
Yeah, I do that, and then I unplug it. I unplug this thing here, so you got to plug in. It's got two things there. I use a one of those little tiny bulbs, the little guys that go. They're a piece of glass that have two wires that go out. If you bend those wires out and actually cut the right one, you can stick it in there. So I stick a light bulb right there. It goes from here right to here. Light bulb. And then I tell this guy, turn me on. Boom. Light lights, turn me off. Boom, light goes off. That's it. If it's got that code, I know that's bad. Right there. I like to check the powers and the grounds at what it actually does. So a blower motor in that van or whatever, that might be a pulse response modulated blower motor. Let's say it was the one that had 1, 2, 3, 1. If you have that, you could check the powers to the battery and you could check the ground to the battery. How long does that take? You gotta string wires, you gotta make sure you got good grounds, you gotta do all that stuff. If I think the blower motor's bad, I will take, let's say this is not a pulse thing here, let's just say this is a motor. Blower motor. I'll take a headlamp bulb, and everybody should make one of these. And I'll put two connectors on it with two spades, so I can just unplug the blower motor, plug my headlight bulb with two spades in there, 1, 2, 3, and they'll get brighter and dimmer, just like the blower motor is supposed to do. If I got that and it doesn't run, I know for a fact that all the circuits are good and the blower motor is bad. Because I'm checking power and ground. Yeah. At the same time, at the connector, where the work has to happen, if you can check both of them there, that's the fastest way, the best way. Because you can check all the parts and pieces, but you could miss something or you could have a bed. If you just do that, it's like boom, done. Another thing that works just this way. Let's say you're trying to figure out the window doesn't go down in that car. Same way. You can go to the motor. Sometimes I go to the switch because you can just pull the switch up and go to the back side of the switch. Then you know that it's at least the switch and all the circuitry is producing it to the motor, because it's a pain in the butt to take the door panel off. But I do the same thing. Anytime I can do that, man, just do it. It's so easy. Anybody else got any questions on that?
Alright, I'm good. Smart.
These little guys make sense.
Yeah, those actually help me visualize it.
Yeah, because there is guys in there making decisions, but somebody told them to look for that in the programming. When you flash it, when Mike flashes a computer back there, he's putting these little guys telling, hey, this is the strategy. When this guy talks to this guy, I need to see that there. He puts that all in there. That's all in the code he writes, or he don't write it. You want to see what an injector will look like on a lab scope? Okay. That should be pretty easy to draw. Same thing here. So injectors don't fire near at 100%. They're
Now, if you were gonna lab scope like a diesel injector, I know on a gas you can back
it's
up
a
the
piezo
connector.
injector. It's gonna have like so quick. They're like they take the microseconds and they put the US. When you see a US, I don't know if there's another symbol there if it goes like that or
But
something.
like on a Cummins to do that, you'd have to pull the whole valve cover off and go on the two prongs on
No.
the top. No, you could go on
Go to
the
the computer.
you could
Wherever
go-
it originates, you can go there. So let's say this is a gas injector now. Injectors are ground side controlled. So I'm going to draw the diagram really quick. We're not hurt cell anymore. So we have 12 volts. It goes like this to the injector. And it's got it's basically like a solenoid, but it is a solenoid, I guess. And it goes down. An injector, so this is the ground side. PCM goes through the little transistor in that guy, and then it goes down to ground. So if you hook the lab scope, I'm just going to put these things here for power and ground. So plus and negative. So if you hook the lab scope, negative because it got to go to the battery. Best place to go on this. Actually, you can do it at the injector as well. No, you can't. No, you can't. So the power side is going to go, we know if we go right here, we're going to have power all the time because it's 12 volts from the battery. Like, it's got a fuse, but that's it. they actually split off. You'll see this, and this is a diagram. If you see that on a diagram and see something else going out here, let's say this is a 4-banger. If you see this, do this, and do this, and do this. And they would also go, these would go to the PCM so it controls each one of them.
Those are your injectors.
Yeah, and this doesn't go to the same place, so we can take this and go to a different compartment. You want to do that thing again? You want to do that thing again?
Yeah.
Okay, so if we went to right here, we would always see 12 volts. It would just be up here all the time, straight across the top, right? So we have to go to the ground side, and I like the back probe all the time. Ground side back probe. So when the computer says I don't need that injector on, we're going to have, you know what? Let's do 24 volts and 12 volts. 12 volts in the middle. The computer says I don't need that grounded, so power flows through the injector back to the computer, power, until the computer makes a decision. It's up here like this. The computer makes a decision and says I'm going to fire that injector. I'm going to ground that injector out so current can flow. It goes down like this. Pulls that to 0. Almost 0 because there's some losses in this stuff here, some losses in transistor wiring. So you're going to see almost go to 0. And it's going to go over here like this. And this is actually going to go up a little tiny bit. And that's called electromotive force. Just remember that. That's really top level, but it is electromotive force. It's going to say, okay, I've been on long enough. This is 2 milliseconds, approximately. It's going to release it. That guy's going to say, okay, we've been on 2 milliseconds, we're going to go way up. Why does that go higher than 12 volts? It actually goes up to 60 volts. On a Dodge product, I think they have a clipper at 60 volts, so it actually goes through the roof here at 60 volts. You know why that is? Anybody know? You collapse that circuit, there's an inductive kick. So you had it doing a bunch of work, all of a sudden that work goes away. Boom. You shut that off, it allows us to go up. That'll go inductive spike to like 60 volts, and they have a clipper. Says I'm not gonna, it's like a resistor clipper or a diode clipper, it's 60 volts. Says okay, and then it comes down and goes back down to that.
So it like bounces it down.
Yeah. It comes back down to the 12 volts again. Until it needs to fire it next time. And there'll be another one of these exactly like that. Okay?
It will look just like that on a live
It will look just like that on a lap scope. Now, the weird part is, let's say you take a magnet and you wrap a magnet and you move something through it. You know how that makes it actually makes a voltage? You didn't know that? Okay, it does. So if you take a magnet, if you wrap a coil, hook it up to not just out here.
Circular magnet or something.
Let's say this is hollow between it, and I'm going to have a magnet. Let's say this is a magnet.
Kind of like how a transmission speed sensor works.
Yes, exactly how transmission speed sensor works. So I'm going to move this magnet through here. I'm going to have this to a volts. I have this on volts. And this goes to here, this goes to here. That actually, when I move this magnet through here really fast, this goes, and it produces if this is 0, it produces goes high and low. It actually makes a voltage. The weird part about this is, this gets a little in depth here. You can actually see on this ramp that comes down, because the injector is exactly that. It moves through the center. You can actually see a pump. I think it goes that way. It's either goes up or down. That's not right. There is a little dip in that, and you can actually see that dip. You know what that dip is? Any idea? It's when the injector physically, mechanically closed because whatever was in there, it actually moved. You can actually see that on the downside. It's kind of crazy. There's another, I can tell you more about that later, but there's a way you can, if you have an amps clamp and this and put them over each other, you can actually see when the injector opens, because the amps will go like this. It'll have a little hump in it as well. And it gets fully open and it does that. So if you lay these on top of each other, you can say, okay, the amp starts going up like this, and let's say it goes pretty straight. It has a bump right here, so between there and there is how long the injector was physically open. It happens really, really fast. Any questions about this? There's a lot there. That's a splice. And then it individually has to fire each one, so the guy on the computer has to make the decision which one to fire when. So this would be 1, 2, 3, 4 on a 4-banger. That makes sense?
Yeah.
So the cool things, remember we were talking about amps yesterday? The really cool thing about amps is,
Persuaded with your razor.
if you have an amp clamp here, and you have your this one over the lab scope here and here, so you can watch if you have amps. So this is going to be like 0 to 2 volts because your amp meter is set up in a ratio. If you have amps, you can watch. So injector 1 fires. This is amperage, not voltage. So it goes here. Injector 2 fires. Injector 3 fires. And injector 4 is flat. Since this is up here, and it feeds, this one wire feeds all 4. Is there a problem there? And this is back to 1 again.
It missed the.
I missed the fourth.
It missed one of them? Yeah. So what could that be? If
That
you,
injector, or wiring to the injector.
so would it be a short? Or open?
Probably an open.
Could also be the computer not, it could be this little guy in here. One of these guys doesn't have any,
His
Draw down.
making skills went down the road.
what?
I said his
Decision-making skills and down drain? Could be. So you've seen me write this up here before, but G-I-G-O. G-I-G-O. You know what that means?
he's like,
Garbage in, garbage out. Garbage in, garbage out. You feed this guy, this little dude's bad information, garbage, you feed him garbage, he'll make garbage decisions every time. Garbage in, garbage out. That's actually, if we don't think about it, that's how our brains work too. We put garbage in our brains, garbage comes out. That's end of story. That's what happens. So let's say we had a misfire. We didn't want to back probe all these things. You can back probe all these things and check them on, lab scopes and stuff. If I have an amps client, which literally it sits right there, and a lab scope sits right there, if you know how to use it, you can go around this, and you can do this with the fuse. You can just pull the fuse out and go around it right there. Injector fuse.
For the fourth one that's not fired.
You can say, okay, all of them are the same. What if, I'm going to draw this a little bit different. Let's say this one was here. So let's say this one was there.
oh man,
How about that now?
Oh boy,
I don't know.
I couldn't tell you. That's
So this is amperage. So I'm using an amps clamp, but it's showing me in real time instead of just like it's 3 amps. It's actually showing me the injector field had amperage, or the circuit had amperage, no amperage. Amperage, no amperage. So this is 1A, and this is 0.5A. Half an amp. What could be wrong with injector? I'm going to call that injector number 1, and the rest of these, since they have less squigglies, is the other 3 injectors. What would cause that to not draw as many amps?
Resistance. Going up.
Resistance going up or down?
Going up.
Okay? So the resistance, the ohms, goes up. The amps goes down, right? The voltage is constant, it's still 12 volts. I like this thing, by the way. This is awesome. I never seen the seesaw there. Like, I learned this stuff without, before that. I didn't have some of the options that, the video training and stuff that we have now. So this one's only pulling half an amp. So let's say, it's 12 volts. So it'll be 12 ohms, 12 volts, 1 amp. So these are 1 amp. So this is This is 12 ohms, 12, and 12. How many ohms is that one?
6. Oh, wait.
Resistance go up or down?
Oh,
Let's equate this guy to this guy. Those are the same ones. Let's just say they are. How many ohms does that one have? If it's pulling 5 amps instead of 1 amp.
6.
6?
no, that one
That would be
would go
24.
So 12 it needs to go up or down. Resistance needs to go up or down.
up.
Resistance went up because the amps went down, right?
Yeah.
Okay. So is it 6 or is it 24?
24.
It's one of them.
24.
24?
I would say 18.
6. How do you get 18 out of there?
Cut it in half. I mean, you
12?
divide-
We got 12 ohms over here. All these have 12 ohms and they're producing 1 amp at 12 volts is
Oh, I'm dividing 12 by 2.
yeah. So
Well, you just need to time it by 2.
times by 2. So this is 12. What's this one here got?
24.
24. Now, that could be at any point from there to the computer. You could have a corroded connector.
Why not after the computer?
It could be on either side after this splice.
Oh, yeah.
Because these are producing good amps. This one's not. So you could have a corroded connector. You got corrosion coming out of the connector, green wire, that kind of thing. Same could be here, it could be here. It doesn't matter. Good morning, Mike. So all these are the same. All these are the same. We know from this point and this point is good because those three are firing good. That one's half the amps. So yeah, does that make sense?
I like that symbol one.
Which one?
That one.
This one? Yeah, this makes sense.
Yeah.
Ohms goes up, amps goes down. Ohms goes down, amps goes up.
I need like 3 of those sitting around the shop.
I'm sure you can go online, but see, they're going to be confusing. This makes sense, volt ohms and amps. They're going to be like I times R equals E. That doesn't make sense in my mind.
Yeah, that one.
Yeah. Okay, so does anybody have any questions about that? How we got there? No? Almost there. Yeah.
So if 1 amp equals 12 volts, why did it, I'm sorry, if 1 amp equals, the ratio to that is 12 ohms.
12 ohms, 12 volts. Divide those two. What do you get? You get 1. So that's 1. 12 volts, 24 ohms. Divide those two.
So if the one
Yeah.
unit, so is this the way my brain's working? If you have 1 amp, it equals, obviously because you're doing the math. So if you have 0.5 amps, how does that equal 24 ohms?
Ohms. Okay. Amperage goes down. Resistance goes up.
Yeah, I understand.
This is tottering right here.
It would be the volts divided by the amperage, so it would be
We doubled the resistance. We doubled the resistance. What's the amps going to do?
But wouldn't it be
We doubled the resistance. What's the amps going to do?
double resistant amps are going to go down?
Down. What's the amps do?
Move down.
Yep. Double the resistance. The amps not in half.
Okay.
Make sense now?
Yeah, it does.
Okay. So I'm going to spread this way out. Let's say this is the time base here. Let me take all this stuff away. Garbage in, garbage out, man. Think about that. G.I. Joe. First time I heard that, I was like, what are you talking about? So let's say this is 12 volts. Okay, so we're still in amperage. 2 volts. But I'm spreading this out. This whole thing is 2 milliseconds. It's like the blink of an eye. 2 milliseconds. 2/1000ths of 1 second. So that would be 0.002 seconds. I think that's right. So, because 200 milliseconds would be 2/10 of a second. Or, yeah, 2/10, 200, this is 2/1000ths of a second. So this is amps. The computer decides to turn it on. So it's called an amps ramp. ramps up. It doesn't, when you put power and ground or something, you think it instantly draws the same amount of voltage or amperage. It doesn't. It takes a little bit for it to ramp up. So it goes like this. You get your little hump here. Not quite that sharp, but you get your little bump. Called a bump. It goes up to the top and it tapers off. And then as the computer lets go of it, the amps drops. The amps doesn't spike because it has no resistance. It's open. Amps doesn't spike, but the voltage does. So the meter commands it on right here. It commands it off right here. That make sense? Okay. So that one injector, instead of going there, it only went to here. And I want to tell you something else. What else is missing that I just drew last time? The little bump.
Threshold of it actually opening.
It didn't actually open probably because it's only half. That make sense? If you zoom in enough on that, what we had there, you'll be able to see. Look, stuff in cars typically quits working at about 7 to 8 volts, somewhere in that range. If you have 7 to 8 volts, it's probably not going to function. Solenoid stopped working. Computers probably stopped working at like 8 volts. Computers stopped working 9 volts.
My Dodge is like 11.
So yeah, because when you hit those starters and you have a bad battery, it kicks it in and out because it's actually stopping the computer. Too much juice. So we kind of covered PWM. A few symbols. Symbols. So this is a GM wiring diagram. PCM. You might have, let's see, it might come in here to a, this would be solid. The new GM wiring diagrams are not maybe as easy to read as the old ones. It goes like here, and it has a connector. And this will say 2, and this would be another thing. Let's say this is injector drivers. They come up here, and this will say 1. And over here it'll say C203. Comes up here, and then you go out here. This will have an injector like we just got, and it'll go up to 12 volts. I guess we're trying to draw. So 1 and 2 that you see beside there, it just says 1, and there's also PK, and this is BK dash OR. Do you know what those mean?
Pink and then black, orange.
Black and orange. That's the color. Do you know what 2137 would mean? Have you seen that by our thing? It doesn't have to be 2137. It would be like 4-digit number. That's the circuit number. Does someone have numbers? That's the circuit number just going to there. The other thing would be probably like a 0.5. You might see a 0.5 there. Do you know what that is? That's it. 0.5. It would be the size of that wire. Like, yeah, you might have a 0.5 there. There's also, again, there's this little dude right here. It might go like that. You might see that there. And if this was a, let's say this is a temp sensor, which would have to, okay, I'm going to draw a temp sensor. And it'll come back, and it'll go back here, and it'll also have this, and this will be return or ground. Return and ground. And this will go here to a thing that looks like this. That is a 5 volts regulator. It doesn't have to be 5 volts, it's a regulator. But I just drew a temp sensor out here, so we have to do a this here, and I think the temp sensor, the thermistor has a thing like that goes through it. As temperature changes, actually some of these will say 5V. As temperature changes, the resistance changes in that. So this goes to ground. Let's say this goes to ground. because the return signal usually goes to ground. And this goes, what do I have there? I have nothing. I've got something about it there, but it doesn't matter. So this will be 4. What's that number right there? What's the 4? What did I say 1 and 2 was? Huh?
Injector drivers.
What?
You said they're injector drivers.
No, the 1 number and the 2 number and the 3 number. We're talking about diagrams here. What's the C203? What is that? What's C stand for?
You said circuit.
Circuit. What did you say?
Connector.
Connector. That's connector 203. You can find those in all data. If you go to connectors, find connector 203. And probably I'm just pulling that on my. You can find that. So connector 203, as long as they're together like this, that's pin 1, pin 2, and pin 4 of connector C203. That makes sense? Why is this dotted and not solid? There's a reason for that. Does anybody know why?
Correct.
No. Nobody knows why? That's fine. I didn't know why until somebody told me either. When a line is dotted like this on a GM, or working on a GM here, when a line is dotted like that, that means there is more wires than what is shown on the diagram that goes to that nodule. That's what it means. That's it. And on a Ford, if you see a wire that goes down here, goes to whatever, let's just say it goes to ground, and it's got little tick marks like this. What the heck does that mean? I don't know. I had a guy at Identifix tell me. That means there's more than one wire that does the same thing. They could have more than one ground. It's stupid because you'll think you have this thing figured out, and all of a sudden you realize, I got more than one wire that does the same thing. So this is 5 volts. This is a resistor. I'm just going to say this is a resistor.
Dave, I have a question.
8 o'clock till they get to work? Okay. I'll just leave this up here, doesn't matter.
His first wave is here, and we got a lot of stuff to go. We got
Okay.
about 26 cars.
Everybody learn something?
Yeah, definitely.
A lot.
Okay.
Thank you.
Yep.